All right, welcome back. Now we are continuing our closing video on the basic Python basics, and we are still building our simple calculator. So this is our roadmap, a quick view of where we are now and where we're heading towards, just to keep us on track, you see. That's basically it. So cool. Without wasting further time, let's jump straight into it. So this is where we left off, and we're just gonna pick up from there and move forward. So let's clear our screen first. Now we had already set up our calculator, just a refresher, that Python runs from top to bottom in the scenario, and the logic is basically to follow what we would usually do on a calculator. So first thing, we grab a calculator, whether it's a digital one or the physical one. We punch in the value for the first number usually, and then we select the operator. It's a plus, a minus, multiplication, division, whichever one, whatever the operator happened to be. I know some calculators have more operators than what you can see on your screen. And then we usually punch in the number that follows after, second number or value, and then we press the equal sign. And the equal sign tells us, hey, now it's time to do the processing. But in our case, our equal sign is basically the logic that we're implementing here. What happened behind that equal sign is what we're doing here. So the operator checks and say, hey, equal sign, I see that you selected a plus sign, then I'm gonna add the number, first number that you entered to the second number that you entered, and I'm gonna display the result. In our case, we're using print. In the calculator, it's just a small screen to show you what the output is. A bit more sophisticated, but you get the concept. So now we are now looking at all the operators. So I'm just gonna copy that and put that in there. But then now we're checking for a different operator, which is going to be our multiplication, right? And then I'm sure by now you pick up the flow. If it's a multiplication, we use a star, and unfortunately you cannot use a multiple sign because that looks more like a string. But the equivalent on the world of machine is basically this little star. Now, if I run this code and I pass in the equation, the star, it will process the information and the result will be so. Now, one thing I also want to highlight while we're on this is that the result in Python allows us to use the same variables all the way through. So assuming that maybe we did some other changes after this processing, the value of the result would change as we progress from top to bottom. So that's something you want to keep in mind, that when you're programming, you need to think ahead of what you want to see being done. So that's a programming part of this learning process that I enjoy, is to be able to think ahead, plan what the moves will be, and what might change along the way, what would not change along the way. That's part of programming. Now we've introduced another operator, so let's run that. Python main, and then we're gonna use simple numbers, and I'm gonna select the star, and I'm gonna say multiply that by 3, and I get a 6. And you notice that the result is 6.0. That's because we are multiplying to float. So your expected output will also be a float. So that's good to know. So that is the operator when the multiplication when it comes to this operator. Now we are going to do the last one, which is going to be the division. I'm sure by now you're picking up the flow. So we're gonna put a forward slash, basically, that's equivalent, and replace our operator with a forward slash. And we're gonna see process that for us. So we're gonna see Python run main. We're gonna say take 10 and forward slash and pass 2, and we get a 5, right? Just like you would on your normal calculator, whichever format you happen to use it. So that is the logic. When you press that equal sign, there is way more use cases behind the scene, and some of them are even more very, very sophisticated. I mean, with the use of AI and the new tech that we have available today, this have become the computing power has dramatically increased. So this is just to give you an idea of what goes on when you press that equal sign. And as you've noticed, it's in a split second, the blink of an eye, and then you have the result. It's that fast. So, and this is just happening on this machine. It's not the most powerful one, but you can imagine with what you can achieve with bigger number, with high computation, with high demands on calculations and all of that, which would take you years if you had to do it with your own mind. But with computers, it's just 1 second and you have the result. So that is what is happening when you press that equal sign. We try to replicate or mimic the scenario and give an idea of how Python can be used to solve a problem more than just code. You know, it's a real life. If you're running a business and you happen to want to build your own calculator for specific use case, then Python can allow you to do that. Build that, package that, and use it every day, just like you would for calculator. I even think of maybe putting it some sort of hardware if you can, but the principle remains the same. That there's a logic that runs behind the scene, and it has to run all the time. So, and it has to be right all the time. So that's what you need to remember. Now, another thing I want to highlight is assuming that, for example, we're going to look at a scenario where you cannot divide a number by 0, right? Cool. So I'm going to say, let's leave that. And we're going to see, we're going to add another condition under the dividing operator, the divider in operator, division operator. So we're going to say if num2, remember this, not equal to, yes, it's coming back. If it's not equal to 0, you know, and if you watch the previous video, we encounter an error when we fail to pass in the operator. As a result, the code generated an error saying the value that you pass is not valid. So this is one way of going about handling errors. Obviously, the code that you write is not perfect. As a matter of fact, it's what is commonly called bugs. It has bugs, meaning it has points of failure where the logic will work, and in some cases it will not, because you need to handle those scenarios. And that's also part of programming, being able to anticipate potential issues that will cause your code not to operate as expected. And one of them being, well, what happens if, for example, I'm giving the first number, but and I'm not given the second number, and I'm asked, and the Python is asked to divide those numbers. I still want to return a value, or maybe want to remind the user to enter a value before doing any processing. That's a thought process behind programming. And this is true for any programming language. So you need to be able to anticipate those things and mitigate them before they happen, or else you're going to have a very bad experience. All your users are going to have a bad experience. I mean, it's not going to be pleasant to want to do something. Imagine purchasing a calculator that cannot add two numbers. Oh, I mean, that would just be painful. Think about it, especially because you spend money on something you thought will help you solve certain problems, and it just happened not to be able to do so. So you want to avoid that by all means. So okay, cool. So this in this case, we saying if the second number is not equal to 2, then what we want to do is pass in, we take our result is equal to the first number, which is that, divided by the second number, and else, so if the second number is not equal to 0, then we do the processing. If it's equal to 0, that's the assumption here. If it's equal to 0, so we're going to say else, meaning there is no other case. So this is by default, this is what you're going to run, which is different from else if. It's another use case. So you're catering for another use case, but in this case is if the first one doesn't work, the second one will always be safe. That's why you're using the else. There is no if. There's no testing or checking or validating anything. So I'm going to say the result will then be equal to, we can just pass a message to say error, which is what you commonly see in some high-level programming environment. We can say cannot be divided by 0, basically by 0. Yeah. So that's what's happening at the moment. So we are saying now, and let's just run it and see how that turns out. So I'm gonna run this, and we're gonna use that division. So I'm gonna say enter the first number. I'm gonna enter the value of 4, and I'm gonna enter the division, and I'm gonna enter 0 just to trigger the logic. Error cannot be divided by 0. And the same goes for, let's say we take 4 again. We're trying to divide that by a negative number. Let's see, -2. We get a -2. That goes in because, well, it's negative. And let's try it with, let's see, 4 again. Well, I think we've covered the scenario. Let's go use a scenario that works. So we're going to say 4, and then we say divide that, and we're going to say 2, and we get out 2. Now, as you've noticed, we have a scenario for the division, and we can do the same thing for the other use case, subtraction, addition, depending on what it is that you're trying to handle. And this require you some thought process, as you can see. And we can have an else for if none of these operators have been selected. So we want to say the result will be equal to invalid operator. Basically, that's what we want. So how do we test that? It means if you're not passing a plus, we're not passing a subtraction, multiplication, or division, then the default value will be that by default. So I'm going to run that. Python. I'm going to say 2, and I'm going to enter some gibberish. Let's say y, and I'm going to enter another number, invalid operator. That's basically it. All right. I think we're going to stop there for today, and I hope you learned something new. Until next time, keep well. Bye-bye.